So the first thing is user one convenience, right? So user need the convenience to use the operating system. So a user need the convenience first of all. So operating system should be easy to use and it should give good performance. Means convenience and the efficiency. So don't care about resource utilization. Who don't care about the resource utilization? The user who is using it doesn't care about resource utilization, that how an operating system is utilizing the resources. That thing will be done by the operating system. So the resource utilization will done by the operating system. How easily we can use the hardware, this is also done by the operating system. How my hardware will give the good performance, this is also done by the operating system, right? But shared computers such as mainframe and supercomputer must keep all user happy. How let's say we have the servers, right? So in, let's say if we have a Google server or Facebook server or any of the servers which we use as a multi-user. So if these servers will not going to serve you, means if you want to open your mail and it is taking a lot of time to open this particular mail, so definitely you will not use that particular services and you will use other mail services. So, but they are looking for efficiency, that how efficiently we can use the resources so that we can fulfill the requirement of all the users. That's why it is saying that in some shared computers like mainframe, supercomputer or server must keep all user happy. And how it will keep all user happy? By utilizing all the resources and by giving all the hardware resources to all the all the users. Users of dedicated systems are such as workstation has dedicated resources, but frequently use shared resources from servers. So definitely the shared resources, the concept of shared resources comes when multiple users are using it or multiple applications are using our system. Workstation means my desktop or my laptop is the workstation, which has some dedicated resources. But if I'm using some shared resources with the help of the servers, so let's say there is a server and this particular server is used by many users. So we have users and all these users are using this particular server. So definitely, because it has only, let's say, the bunch of hardwares available, let's say we have in the server, let's say 16 core CPU is available, right? So if we have 16 core CPU available, means 16 user can, or 16 application can interact very easily. So it will do like that. Who will? The server will do like that with the shared resources. It will share the resources and it is the responsibility of the operating system to manage all this. Now the next point is handheld computers are resource poor, optimized for usability and battery life. So definitely if we have the computer available with us, let's say my laptop or my iPad or my computer system. So here the responsibility of the operating system is to optimize the usability so that the battery would be used less, or we can use less battery for that, so that we can optimize it. Let's say if I'm not using the computer system, it will go to the sleep mode. If I am not using something, it will try to optimize it or try to harvest the energy of my system. Then we have some computer where we have no user interface, such as embedded computers in devices and automobiles. So let's say if we have some embedded system, let's say we have hardwares like let's say you all see access controls or switches. So all those, or the routers, all those devices doesn't actually very little user interface is required or no interface is required. So on those type of embedded system, uh, the user will not interact with it, or user cannot directly interact with it. Okay, so depend upon the event, it will do the processing. Like in automobile system, or in automobile systems, there are the operating system available, but these operating system will not be taken by or not be used by the user. Okay, depend upon the event, different events of the automobile, it will act. So there are embedded system. Embedded system means the software or the operating system is there in these system to do some dedicated work. So there are some dedicated work which is defined based on the event, and once the event triggered, this embedded system will do something. Or let's say if event one will occur, then we'll do that. Event two will occur, then we'll do. So pre-described event and the actions are there with the help of the software or the operating system that will put into the embedded systems. So embedded system has, you can say that it is the hardware which has the dedicated software, right? Embedded system is nothing but some sort of hardware which has the dedicated software which will work for that particular hardware only, and based on the events it will trigger. So this is about your operating system, that what operating system will actually do. So, okay. We have some, how we can define the operating system. So the definition in one line, we can say that it is an interface between user and the hardware. But we have some more related to the definition, and that is here. Like operating system is a resource allocator. Yesterday we have gone through that what is the responsibility of the operating system. So one of the responsibility is resource allocator. And what happen when operating system will allocate the resources? It means it will manage all the resources, and it will decide about between conflict request for efficient and fair resource use. So if we have, let's say, two or three program available which want to use the same amount of or same hardware, so it will resolve these conflict or these ambiguity in an efficient and fair manner. So all the application that will be submitted into the computer system should be uh, means efficiently and fairly taken care of. That is the responsibility of operating system. What is an operating system? It is a control program. It controls execution of program to prevent errors and improper use of the computer. So you can say that operating system is nothing but the control program, a sort of control program whose responsibility is to control execution of program to prevent error and improper use of the computer. Means properly the program should execute, and properly program should execute without the error. So that is the responsibility of the operating system, and we can say that operating system is a control program also. So the one program running at all the time in the computer is kernel. So kernel is running in the computer system, and this is also a, as I told you, is a program, and it is also a control program. It is a heart and soul of the operating system, kernel, and it is always running into the computer system. So once you on your computer system, kernel is running. Everything else is either a system program. So either we have the system program, which is the program related to the operating system which is running, or application program. So these type of two programs are always running into your system. Either it will will be a system program or it will be an application program. So what is a system program? Any program related to the operating system is called system program. And other programs like your word processing, your browser, your web server, your compiler, all those other programs are called application program. So in your system, either of these should run or it should running. Okay. And in the system program, you can say that many device drivers like we have display card, we have Ethernet card, we have different hardware attached to it. Let's say if I'm using the keyboard of it, right? Or I'm using the mouse or the keyboard. So it has the associated device drivers which will control the hardwares and all. And all these device drivers are nothing but the system program. So these are one category of system program. There are different other category of system program, means dedicated, some dedicated functions are there which are also comes into the category of system program. So this is all about the definition of the operating system. Okay, the responsibility. So we have discussed it earlier. The responsibility of the operating system is resource allocator and resource manager. And what are the resources we have? So we have resources. So let me tell you about what resources we have. So the first resource we have is CPU. Okay, how we are utilizing the CPU. And CPU will be utilized by any sort of process. Any sort of process. Process is nothing but the instruction under the CPU for execution. Second is memory. Memory is nothing but your main memory. What is main memory? RAM, random access memory, that will use. And this particular RAM is not only the RAM. This particular RAM is, let me tell you what is this. This particular RAM is DRAM. Okay, this particular RAM is DRAM. DRAM is dynamic random access memory. I'll tell you about it. What is static random access memory? What is dynamic random access memory? But it is a memory. The third resource that has to be handled by this operating system is your IO, input output devices. And there are different categories of input output devices. So what are those? So we have like keyboard, mouse, display. Display is your screen or your console, right? Then we have printer, and we have your disk. It's called hard disk, or it is your secondary memory. Okay. So what we are going to learn in the operating system is that how these resources will be allotted, or these resources will be given to the program or to the user, right? Because user is interacting through the program. So we can say that these resources are available to the program, that will see, and how we are managing those resources, So we are going to see that how we can do process management. We can see memory management. We can see disk management. So all these type of management we'll see one by one in the operating system courses. So